Hello, welcome to homework questions 55 through 60 from Chapter 6. Question 55. In problem 6-24, you looked at the data for a study conducted on a vitamin supplement that claims to shorten the length of the common cold. The data is represented in the table below. So we got a couple different questions here. The first one, find the LSRL, create a scatter plot on graph paper, or use your scatter plot from problem 6-24 and draw the line of best fit. What is the equation of the line of best fit? So I'm going to use this graph to do my scatter plot and then use the calculator to find the LSRL and graph it as well. Alright, so I've plotted the red points, which are my scatter points, my scatter plot points from the table. I then calculated the least squared regression line, so I have y equals negative 1.5x plus 5.37, and then I was able to graph that line. I chose the point 0.5, and it was about 4.58, so a little bit above the red point, and then the other one I chose was 1.5, and 1.5 was right about 3 almost exactly. So those are the 2 points I chose to graph the line. So that is my line y equals, let's go back, y equals negative 1.5 x plus 5.37. And I got that from the graphing calculator. Alright, so part A is done. Now B, draw the upper and lower boundary lines on the graph following the process you used in problem 6-23. What is the equation of the upper boundary line and then of the lower boundary line? So you might need to go back to question 6-23 to remember how to do upper and lower bound. So to answer question B, I had to find the largest residual, and I chose the point 1,3. It looked like it was the farthest away from the least squared regression line. So I found that the distance between, so I had to find the actual point, which was 1,3, and then find the predicted using my least squared regression line, and it was predicted to be 3.79. So the difference between my actual and predicted was negative 0.79. So once I knew that, then I could create my new line here at the point 1,3 with a distance of negative 0.79 and given the same slope of negative 5.8. So I was able to kind of copy that line below. That would have been my lower bound. And then my upper bound, I had to do the same thing. So I created this distance right here, 0.79. I went up 0.79 approximately, and then graphed that line with the same slope. So to be able to write the equations of the line, because my residual for the maximum point away was 0.79, I'm just going to take my y-intercept of my least squared regression line and add 0.79, keeping the same slope, and subtracting 0.79, keeping the same slope, because they are parallel. So if I keep the same slope for my upper bound, negative 1.58x, and then I add 0.79 to 5.37, I will get 6.16. And if I do the same thing for my lower bound, I keep the slope the same, and then I subtract 0.79 from 5.37, I get 4.58. So those would be my two upper and lower bounds. So I'll go back to part B and just make sure what is the equation of the upper bound line. So I'm just going to say that the upper bound line is going to be y equals negative 1.58x plus 6.16, and then the lower boundary line is equal to y is equal to negative 1.58x plus 4.58. Alright, on to part C. Based on the upper and lower boundary lines of your model, what do you predict is the length of a cold for a person who has taken the supplement for 3 months? Consider the precision of the data and use an appropriate number of decimals in your response. So to answer this question, we want to use our least squared regression line to figure out what the predicted number of days a cold would last for 3 months. So I'm going to plug in 3 for x into our least squared regression line, calculate what that is, and I get that to be 0.63. So that's the number of days if we're predicting. But based on the upper and lower bound and the residual, that maximum residual being 0.79, I'm going to take 0.63 and I'm going to add 0.79 to kind of get that maximum value, and then I'm going to take 0.63 and subtract 0.79 to get that minimum value. So on the maximum side, I get 1.42 days, and then on the minimum side, I'm going to get negative 0.16, which we can't have that, negative. So to answer the question, consider the precision of the data. All the decimals in terms of the number of days are being rounded to the nearest tenth, so we'll do that as well. And then make sure we answer the question, what do you predict is the length of cold for a person who has taken the supplement for 3 days? We would say anywhere between, and we're not going to say negative, we're between 0 and 1.4, now rounded to the nearest tenth, days. On to part D, it says, how long do you predict a cold will last for a person who has taken no supplement, which kind of means interpret the y-intercept in context. So the first part, the y-intercept of the least squared regression line is 5.37. Once again, we want to use our upper and lower bound to make a good prediction for that, though. So we want to take 5.37 and subtract 0.79. I'm going to take 5.37 and add 0.79. And that'll kind of give us that range if they do not take a supplement. So if we take 5.37 and we subtract 0.79, we get 4.58. And if we take that 5.37 and add 0.79, we will get 6.16. So once again, rounded to the nearest tenth, we would say if they did not take a supplement, how long we would predict the cold to last. We would say between 4.6 and 6.2 days. And in context, in terms of the y-intercept, I mean, it basically does represent how long a cold would last if a person didn't take any supplements at all. Part E, how long do you predict a cold will last for a person who has taken 6 months of supplement? So once again, we take this least squared regression line and we plug in 6 months. And as we plug this in, be aware that our data for the number of days taken a supplement only went as high as 2.5. So we're really going beyond our data on this. So let's see what happens. Y is equal to negative 4.11. So obviously we have a little problem here. We're getting negative number of days based on, a person taking a supplement for 6 months. So because we're getting, too far beyond our data, we shouldn't, make a prediction. Obviously, negative days doesn't make any sense here, but also statistical models often cannot be what we call extrapolated far beyond the edges of the data. So if we get too far beyond our data, sometimes our predictions are not going to make any sense. So in this case, we don't really want to make any predictions for a person who is taking a supplement for 6 months. And then the last question, F. If you have a cold, would you prefer a negative or positive residual? And think back to your graph here, having a negative or positive residual. Well, it looks like we would prefer a negative residual, so we would want something down here like this one. Because what that means is the actual cold was shorter than what was predicted by the model. So ideally we would want a negative residual, once again, because the actual cold was shorter than what was predicted by the model. So that finishes up question 1. Obviously, question 1, but question 55. Obviously a lot going on there, really bringing in and tying in a lot of the things that we have done in Chapter 6. get through as much as you can. Just think about what we have done, and always go back to the problems that we've used and the core problems to work through these, and just do your best. And obviously, if you have any further questions, you can ask your teacher.
Question 56. Write an explicit equation for the sequence graph below. Well, when we graph, we need to know what kind of sequence is it. Is it arithmetic? Is it geometric? So let's start by just labeling what these points are. So this is the point 4, 2, 3, 4, and 2, 8. And I probably should start with point 2, 8, but either way, it doesn't matter. So if you look at this in terms of a table, if that kind of helps you see things, that might help also. So my x-axis is n, my y-axis is t of n, and so n is 2, y is 8. When n is 3, y is 4. When n is 4, y is 2. I'm saying y, but t of n is the output. And so what is happening? Well, how do you get from 8 to 4? You have to multiply by 1/2. 4 to 2, multiply by 1/2. So we need to go back and find the initial value, which is at n equals 0. So we have to work backwards. So if I'm going to go this way, I need to multiply by 2. So that would be 16. Once again, 16 times 1/2 is still 8. But then multiply by 2 and get 32. So there's that initial value that I need. Okay, that's part of my equation. And I also need what the multiplier is, which is 1/2. So we have everything we need to be able to write the explicit equation. T of n is equal to my initial 32 times my multiplier 1/2 raised to the n power. So there's how you write your explicit equation. The 32 is the initial, the 1/2 is the multiplier, because that's what's happening to get to the next term over and over again, and then raise it to the nth power.
Question 57. Graph the points -3, 2, and 5, -4. A, find the slope of the line determined by them, and B, find the distance between them. Hint, Pythagorean theorem. All right, so let's first plot the point -3, 2. So x first, so we're going to go left 3 units, and then y is the second number, so -3 and then up 2. So here's the point -3, 2, and then 5, 1, 2, 3, 4, 5 to the right, and then down 4. So there's the point 5, -4. First, find the slope. We can use slope triangles. We can use the slope formula. However you want to do that is fine. So just to kind of show you, try that again. All right, so the distance, the slope, is the change of y over the change of x. So if I'm just using the graph, I can count 1, 2, 3, 4, 5, 6. So I went down 6, which is a -6, and to the right, 1, 2, 3, 4, 5, 6, 7, 8. So if I'm using the slope triangle, then I have the change of y is -6, the change of x is 8, and then I can reduce that by a factor of 2 to get -3/4. So my smaller triangle could be, change colors, here to here, and then down 3 and over 4 again. Okay, so that represents the slope. The other way that I could have done it is by taking the change of y algebraically, so 2 minus -4, and -3 minus 5 for my change of x. That would give me 6 over -8, which still reduces to -3/4. So either way was fine. Part B, find the distance between them. So to find the distance between 2 points, maybe you've learned the distance formula. It's one of those formulas that sometimes students memorize, but I like the fact that it says, hint, use the Pythagorean theorem, because really the distance formula is the Pythagorean theorem. And so Pythagorean theorem, most students at this point know, but the Pythagorean theorem is a squared, just in case, plus b squared is equal to c squared. And the a represents the leg of a right triangle, and the b represents the other leg of a right triangle, and then the c is the hypotenuse, which is the side across from the right angle. So here's your right angle. And it's also the longest side. So if we're going to use Pythagorean theorem, this side length would be a positive 6 because it is a distance, so we're not looking at direction or anything. And then this side length is 8. So to find the distance, we could take the first leg squared, so 6 squared, plus 8 squared, and to find that distance, it's equal to c squared. So we square both of these, 36 plus 64 is equal to c squared. And then 36 and 64, if you add those up, you get 100. And then what squared gives you 100? Or you can use the inverse, take the square root of both sides, and 10 is equal to c, or the absolute value c. So technically there's really two answers to this. There's two numbers that you can square and get 100, but the negative 10, since we're talking about a distance, doesn't really make sense. So find the distance between them. Therefore, the distance between the 2 points is 10, and we'll just say units here. And that's how you can find the distance between 2 points. Question 58, graph y equals x minus 2, quantity squared minus 1. Completely describe the graph. So completely describe the graph. That goes back to one of our learning logs that I believe we did in chapter 1 or 2. So if we're going to graph this, we still are learning about how to graph quadratics. We haven't completely really got into that just yet, but we can always graph something by using our tables. So I'm going to create an xy table. And because it is a quadratic, we might remember that it should be U-shaped. All right. And so when we go to plug numbers in, it's hard to really at this point guess because we don't know a whole lot about these, but let's just start with kind of -2, -1, 0, 1, 2, and let's see where that gets us, and then we can kind of go from there. So all I'm going to do is plug in each of these values into the equation and then solve for y. So if I plug in -2, that will be -4 squared, and it is -4, the quantity, so when you square it, you will get a positive. 16 minus 1 is 15. Now, on my 10 by 10 graph, it's not going to fit, but that's okay. Let's see what happens as we plug in more values. So y is equal to -1 minus 2 squared minus 1, and that would be -3 squared minus 1. So now when I square -3, I get a positive 9, so my numbers are getting smaller. 9 minus 1 is 8. So that one fits on the graph. Now we go to 0, and we just keep doing this. -2 squared is 4. 4 minus 1 is 3. So that would be 3 here. 1 minus 2 squared would be -1. -1 squared is 1. Let me go back and fix this real quick. -1 squared minus 1. So this would be 1 minus 1, which is 0. So my numbers are getting smaller. They're getting closer together. But if it's a U-shaped graph, I need to see those numbers come back and get some repeats. I'm going to continue on here. I'm going to plug in 2. So 2 minus 2 squared minus 1. We get 0 squared minus 1, which would be -1. So I still don't have any repeats. So I'm going to continue my table on for a couple more numbers here and see if I can get anything else. If I continue it in the other direction, the numbers are going to get larger. So let's keep going here. Y equals 3 minus 2 squared minus 1. And hopefully what you recognize at this point is right here I have 1 squared, which is the same as when I had -1 squared. Because whether I square 1 or -1, the quantity, I get 1. So 1 minus 1 is 0. So there you start to see that first repeat number. What do you think is going to happen when you plug in 4? Well, 4 minus 2 is 2. 2 squared is 4. Well, we had one of those earlier, but it was -2 squared. But either way, you still get 4, and your output is 4 minus 1, which is 3. So once again, you see another repeat. What do you think is going to happen when you plug in 5? You will get 8 because you're going to get -3 squared, which is similar to this one right here. Okay, so there is a pattern. It's not linear, though. It's not exponential either. There's a different pattern here. But that'll give us enough to plot the points that we need to. So I'm going to start with -1 and plot 8. 0 is at 3. 1 is at 0. 2 is at -1. And then at that point, it started to repeat those values. So you can see the U-shaped graph, and when you draw it, make sure you make it using curves. Don't draw it using a straight line. Okay, it is a U-shaped graph. So now we need to completely describe the graph. So if you want, go back to the learning log where we talked about how to completely describe a graph and start listing out all the things that you can say about this graph. All right, so here's the list I came up with. Parabola, it opens up. The graph decreases until x is equal to 2, so the y values are going down, and then at x equals 2, it starts to increase. The vertex is at 2, -1, and if you just called it a special point, that's fine for now. The x-intercepts, it crosses the x-axis at 1, 0, and 3, 0. Make sure you write those as points. And it crosses the y-axis at 0, 3. The line of symmetry is at x equals 2, so you can see I graphed that in there. I also graphed all the red points, which are your special points, the intercepts and the vertex. And then the domain is all real numbers. You can plug in any value for x. And the range, though, the range doesn't go down forever. Its smallest point is going to be that minimum value at 2, -1, which is the vertex. And I guess I could have added that as part of my description, that there is a minimum point. And so the range is y values greater than or equal to -1. And the last thing I said is it is a function, so it does pass the vertical line test. For every x, there's exactly one y. So that's question 58, going through and graphing a quadratic. Question 59, copy each generic rectangle below and fill in the missing parts. Then write the equation showing the area as a product and the area as a sum. So you're given a 2x3 rectangle for part A. You're given a side length of -3. And on the other side, you're given -4y. And then you're given 3 of the 6 areas. So we're going to have to kind of work backwards here to figure this out. So for example, I need to take -3 times this side length to get -6x. So we can work backwards, or we can just ask ourselves, -3 times what gives us -6x? If we work backwards, we want to know, what times -3. So -6x divided by -3 would be 2x. So that means I should have a 2x here. And we can just double check. Is it true that -3 times 2x is equal to -6x? And it is. So we know that's 2x. We have -4y. We can actually figure out the area because we have -3 times -4y, which is a positive 12y. So we have that one. And then kind of the same thing on the last one we just did is -3 times this side length gives us -15, or -15 divided by -3 is what? And that's 5. So if I make this 5, -3 times 5 is -15. Now, we need to figure out this side length to be able to figure out the other two areas. So right now, I don't have an area here, so I can't use that. I got to use this second box here. Knowing that this is -4y, what is this side length? So we can work backwards again. -20xy divided by -4y. So -20 divided by -4 is a positive 5. The y's are going to cancel as well, so that's just 5x. So let me erase some of this right here. Alright, so this should be a 5x. 5x times -4y is equal to -20xy, and that works. So now we can take 5x times 2x, so that's 10x squared, and then we can take 5x times 5, and that's 25x. Okay, so we filled it in, and then we also need to write it as an area as a product and area as a sum. So as a product, it's the side lengths. So one of the side lengths is 5x minus 3 times the other side length is 2x minus 4y
plus 5. So if we multiply those two together, we get the 6 areas. And just combine any of the like terms that you can as you do this. So I got, if I'm looking here, I have a negative 6x and a 25x. Those can be combined. And then it looks like everything else is going to be things that are not like terms. So let's go ahead and write this. We have 10x squared minus 20xy. Then I'll combine the 25x minus 6x, so that's plus 19x. I still have a plus 12y, and then a minus 15. So double check, make sure I didn't forget to add any of the like terms up. And it looks like we're good. So we have the area of a product, so length times width is equal to the area of the 6 rectangles. And that's 10x squared minus 20xy plus 19x plus 12y minus 15. All right, now part B. So this one we have a 2 by 2. So x times what gives you x squared? X times x. And then on this one, we have to figure out what's going to give us this 12 here. And we actually have a couple possibilities, because what two numbers, if I just call this, let's call it A and B. Oops, put it in the wrong spot. Sorry about that. If this is A and this is B, A times B is equal to 12. What numbers could that be? That could be 1 and 12, 2 and 6, or 3 and 4. So we have a couple different possibilities here. And these are the ones that work out nice. You know, we could pick other numbers that don't go into 12 even, that are including fractions and things like that, but these are the nice ones. So we'll pick one of these. We'll say, and once again, you can really pick any ones you want there, because we don't have enough information otherwise to pick the exact unique answer. So I'm just going to call it 3 and 4. If I do that, this would be a 4x and this would be a 3x. And if that's the case, then my product would be x plus 3 times x plus 4. Those would be multiplied together, and that would give me x squared. And you can see on this one, the 3x and the 4x can be added together, so that's plus 7x plus 12. Here are your other possibilities with those combinations. It could be x plus 2 times x plus 6, and that would be x squared plus 8x plus 12. Or if we use the 1 and 12, we get x plus 1 times x plus 12 is equal to x squared plus 13x plus 12. But if you notice, every single one has the x squared and the 12. It depends on what we use to multiply to get to the 12. And question 60. Copy and complete each of the diamond problems below. The pattern used in the diamond problem is shown at the right. Same thing we've been using throughout the textbook. So we have some more diamond problems, and we're going to go through and see if we can complete these. Remember, we want to add to get the x and y, and then we want to multiply to get the x and y. So if this is x, it's saying 5 times x must equal negative 25. And if that's the case, if you divide by 5, x must equal negative 5. And I'm kind of showing some work here. It doesn't mean necessarily that you have to show that part of it, but it's just thinking about it. So negative 5 times 5 is negative 25. It's the only one that'll work. And then if you add those two up, you get 0. Okay? Let's take a look at B. B, you're given x and y, so you can just multiply those to get negative 16 and add them to get 6. So when you're given the x and y, it is a little bit nicer because you can just multiply and add to get to the two pieces that you're missing. On C, you have two numbers. Once again, I'm just going to call this x. You have two numbers that have to add to give you 9. So x plus 6 must equal 9. So if you subtract 6, what must you add to get the 9? It must be 3. So I'm going to move that x, put a 3 here. So 3 plus 6 is 9, and then 3 times 6 is 18. Now on D, you're given the product and the sum. So now you got to think about this. I'm just going to call this x and y. So x times y must equal negative 20, but x plus y must equal 19. So you can add two numbers and get 19
lot of different ways. But multiplying to get negative 20, you don't have as many options. You have 1 and 20, 2 and 10, 3 doesn't go in evenly, at least, 4 times 5. Now, it is a negative 20, so one of these numbers does need to be negative. So those are kind of your options. What does it look like that can multiply to give you negative 20, but also add to give you 19? And it looks like if I take negative 1 plus 20, that would give me the 19 that I also needed. So it looks like we found the answer, negative 1 and 20. It multiplies to give you negative 20, but adds to give you 19.